about volumes of revolution. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, we shall study this shaded region, right? And for this shaded region, it is bounded by the curve y is equal to f of x. The lines x is equal to a, x is equal to b, and there's all the x-axis. So now, if we rotate this shaded region, right, through 360 degrees about the x-axis, we form this solid, right, which we call a volume of revolution, right? So the volume of the solid formed, right, after we've rotated this shaded region through 360 degrees about the x-axis, V will be given by pi integral from a to b of y squared by dx. Right, so this is how we obtain the volume of the solid formed. Right, but this is when the shaded region is rotated about the x-axis, so we integrate with respect to x. Right, in situations whereby we've got a region, right, that is, say, rotated about the y-axis. So there's y-axis and then there's the x-axis. So let's say this region has been rotated about the y-axis. We'll form a solid like that. And then our volume will be given by pi integral from the limit, say this is c up to d. So from c to d of x squared by dy, right? So these are the core two important results that we have to know, that for a region that is bounded by, or for a volume that is obtained after a rotation about the x-axis, we integrate with respect to x. And for a volume that is obtained after rotation through 360 degrees about the y-axis, we integrate with respect to y. X squared with respect to y, then y squared with respect to x. So now I would like to attempt those 4 questions. So allow me to read this. Right, allow me to erase this and put the quotable results that we shall use. So we said about the x-axis, v is given by pi integral from a to b of y squared by dx. And about the y-axis, v is given by pi integral from c to d of x squared by dy. Right. So number 1 says find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. So about the x-axis, we say v is given by pi integral from a to b, which is from 0 to 2, right? Integral of what? Of y squared, right? By dx. But now we've got y being equal to x to the power 4, and we need y squared. So y squared would be x to the power 4 squared, which is x to the power 8. Then we're saying v is pi integral from 0 to 2 of x to the power 8 by dx, which would be equal to pi x to the power 9 over 9 from 0 to 2, like this, which would be pi 2 to the power 9 over 9, right, minus 0, of course. This would give us 512 over 9 pi. Right? So this is the result that we get for number 1. Now moving on to number 2. Number 2 says find the volume of the shaded region when rotated through 360 degrees about the y-axis. So now we're rotated about the y-axis, we say v would be given by pi integral from the limit c to d, which is 1 to 2, of x squared by dy. But now if y is equal to x squared plus 1, then making x squared the subject of the formula, x squared will be equal to y minus 1. So instead we're saying v is pi integral from 1 to 2 of y minus 1 with respect to y, which is pi y squared over 2 minus y from 1 to 2, which will give us, substituting the upper limit first, we've got pi then 2 squared over 2 minus 2. That's 4 over 2 minus 2, which is 0. So saying 0 minus, substituting the lower limit 1, saying 1 squared over 2, that's a half, minus 1, that's minus half. So we're simply saying 0 minus minus half, which will give us a half times a pi, that's half pi, cubic units, right? So this is the result that we get from number 2. Then now moving on to number 3. Number 3 says, find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. So about the x-axis, we more like form a chord, because we're going to have something like this. This will extend here. Then we have something like that. Then we have a chord like that. Right. So now, to find the volume here, this has been rotated about the x-axis. So for number 3, we're saying v is equal to pi integral from 0 to 4. From 0 to 4. Right. Of what? Of y squared by dx. Right. So now from the equation here, we need to make y squared subject of the formula, or we need to formulate y squared. So first of all, making y subject of the formula, we've got 12 minus 3x over 4. Right. So this is our y, which implies that y squared would be pi integral from 0 to 4 of y squared. Y squared would be what? Would be 12 minus 3x over 4 squared, like this, by dx. And now simplifying that, we get, we can take out the 16 here, 1 over 16, such that we've got pi over 16 integral from 0 to 4 of 12 minus 3x squared by dx, which is pi over 16 times, if we integrate, we're saying 1 over a times n plus 1, our a being the derivative here, so there's minus 3, so then minus 3 times n plus 1, 2 plus 1, that gives us a 3, then we've got 12 minus 3x to the power of 3, and with our limits from 0 to 4. Right, so now continuing this calculation, here we get a minus 9, so there's pi over 16 times minus 9, that's minus 144. So we've got what? We've got, okay, so let me erase this part. So I'll continue at the top there. So you're saying we've got pi over minus 144, right? And then now substituting the this is to what? This to 12 minus 3x to the power of 3 from 0 to 4, right? Which would be pi over minus 144 multiplied by substituting the upper limit. We're saying what? We're saying what is it again? 4. 12 minus 3 times 4, that's 12 times 4. 12 minus 12, which gives us a 0. So this is 0 minus, substituting the lower limit, we're saying 12 minus 0 to the power of 3. This is 12 to the power of 3. So 12 to the power of 3, see what we get. We get 1728. When I was simplifying this, that's minus pi over 144 times minus 1728. And that divided by 144, we get a 12 pi. So 12 pi cubic units is the volume that we get after we rotate this through 360 degrees about the x-axis. Here, of course, the negatives cancel each other. And now, looking at the last question, which is number 4, so I shall erase this level. So now this is number 3. Right now, we look at number 4. So number 4 says the shaded region is rotated through 360 degrees about the x-axis. Right? Find the exact value of the volume of revolution obtained. So for number 4, what are we saying? We're saying that V, right, this is about the what? The x-axis is equal to pi integral of y squared, let's say y squared a, right, minus y squared b, right? Sorry. This is to be y squared, right? And then this with respect to x. So let's call this this is definitely a. The curve above is a, and the curve below is b, right? So we're saying that now formulating the y squared, right? Y squared for this one we know is 32 already. Then now y squared for this one would be x cubed to the power of 2, which is x to the power of 6. Such that we are saying that v is pi, and the limits is from 0 up to a, for which we don't know a. But we know that a is the intersection of these two curves. So now if you find the point of intersection, if y is equal to x to the power of 3 and y squared is equal to 32, we're saying that what? We're saying x to the power of 6 is equal to 32, and x is equal to the 6th root of 32, right? And I suppose we could leave it like that. Let's see, 6th root, let's see, 6th root of 32, yeah, would rather leave it and use it in its exact form like that. So that is the upper limit. So saying pi times integral from 0 to the 6th root of 32, right, of y squared a being 32, right, 32 minus y squared b being x to the power of 6 by dx, right, those will be equal to pi 32x minus x to the power of 7 over 7 from 0 to the 6th root of 32, right? Now substituting the upper limit, is in pi multiplied by 6th root of 32 times 32. Those will be what? 6th root of 32, 6th root of 32 times 32. Right, okay, let's use it in exact form as well. So now, easy conversion, 6th root, that's 32 to the power of 1 over 6, and then times 32, that's 32 to the power of 7 over 6, right, minus 32 to the power of 1 over 6, right, raised to the power of 7, right, that would give us 36 to the power of 7 over 6 over 7, then minus the lower limit is 0 there, so this will be pi, if we factor out this, times 36 to the power of 7 over 6, 1 minus 1 over 7, it will be pi times 36 to the power of 7 over 6, times 6 over 7, this, which is 6 over 7 pi times 36 to the power of 7 over 6. This, so now let's see if we can simplify that. 36 to the power of 7 over 6 times 6 over 7. Right, of course, this is the answer that we get. Right, which we can decide to write as 6/6 root of 36. Why am I saying 36? Yeah, okay, yeah. Also, it's supposed to be 32 actually. So here's the 32. 32. We'll go 32 there, 32 here, 32 there, and 32 here. Like this, like this, 32. So this to the power of 7, right, over 7 times pi. So this is the result that we get for the last question, right? this is what we get for the last question. And then now it says find the exact value. So we're not supposed to round off anything there. So we could leave it like that. 32 to the power of 7/6 times 6/7. Right, then times pi. Yeah. So we would rather leave it like that since it is required in its exact form. Okay, so this was looking at volumes of revolution. And please make sure you leave a comment, drop a like, and don't forget to subscribe. Thank you.